Good morning, everyone. So let us start the next topic. Planes passing through the intersection of two planes. Planes passing through the intersection of two planes. Is the video and audio clear to you? Okay. So let us start. See, we know how to write the equation of plane. First one is when a normal unit vector from the origin and the perpendicular distance from the origin is given to us. That is the first type. The second one is a perpendicular vector and a point on the plane is given to us. Third one is three non-collinear points given. And the fourth one is intercept form. And now this is planes passing through the intersection of two planes. That means we are given two different planes and the planes are intersecting. When two planes, the intersection of two planes means it is a line. So through that line, infinitely many planes are there. We can find a plane passing through the intersection. That means the line of intersection. So let pi 1 and pi 2 be the equation of two planes. Be the equation of two planes given by vector r dot n1 cap is equal to d1 and vector r dot n2 cap equals d2. So you are given two different planes here. And suppose these planes are intersecting. Then through the line of intersection, we have to find another plane passing through it. Equation of the plane. Equation of the plane passing through the intersection of these planes is given by pi 1 plus lambda pi 2. That is first equation plus lambda into second equation. So let us consider this one. Vector r dot n1 cap plus lambda into vector r dot n2 cap, this is equal to d1 plus lambda d2. This is what we have to do, or we can write this as r dot n1 cap plus lambda n2 cap. This is equal to d1 plus lambda d2. So to find the equation of a plane passing through the intersection of these two planes, the first plane, that is r dot n1 cap plus lambda into n2 cap, is equal to d1 plus lambda d2. So we will get the equation of a plane passing through the intersection of these two planes. Where lambda is any scalar. First equation plus lambda into the second equation. And if there is any condition given to us, apply that and find the value of lambda and substitute it here. That is what we have to do. Is it clear? Two different equations are given, two different planes are given to us. So to get the equation of a plane passing through the intersection of these two planes, first equation plus lambda into the second equation. And if there is any condition given, apply that condition, find the value of lambda and substitute it here. Is it clear? Okay, let us write one question. Find the equation of the plane passing through the intersection of the planes 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2 equal to 0 and the point 2 to 1 and the point 2 to 1. So here find the equation of the plane through the intersection of the planes 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2 equal to 0 and the plane passes through 2 to 1. See, these two are given in Cartesian form. In vector form or Cartesian form, whatever may be the equation of the plane, first equation plus 3 equation of the plane passing through the intersection of the given planes is 3x minus y plus 2z minus 4 plus lambda into x plus y plus z minus 2, which is equal to 0 plus 0 lambda, that is equal to 0. First equation plus lambda into the second equation. Okay, let us regroup the like terms here. Consider the x terms containing x. It is 3x plus lambda x. So we can write this as 3 plus lambda x. 3 plus lambda x. Then here grouping the terms containing y, this minus 1 plus lambda y, then plus grouping the terms containing z, it is 2z plus lambda z. So we can write it as 2 plus lambda z. Then constant terms here plus minus 4 minus 2 lambda equal to 0. Is this step clear? Okay, see now this is the equation of the plane passing through the intersection of these two planes, and it is given that the plane passes through the point 2, 2, 1. That means this equation satisfies the values of x, y and z as 2, 2, 1. Okay, this is the equation of the plane passing through the intersection of the two given planes, and it also satisfies the values of x, y and z, that is 2, 2, 1. Substitute x as 2, y as 2 and z as 1 and get the value of lambda. Three plus x is equal to 2, y is equal to 2 and z is equal to 1 satisfies the equation. Therefore 3 plus lambda into 2 plus minus 1 plus lambda into 2 plus 2 plus lambda into 1 plus minus 4 minus 2 lambda is equal to 0. Solve this and get the value of lambda. You can consider this as equation 1. So what's the value of lambda? On simplifying, did you get this? It's the value of lambda minus 2 by 3. Okay, so you got the value of lambda as minus 2 by 3. Now we have to substitute this value of lambda in equation 1. In equation 1, we consider this as equation 1. Substitute the value of lambda here. So it becomes 3 minus 2 by 3. It becomes 7 by 3x. Then second part is minus 1 minus 2 by 3. Minus 5 by 3y. Then third one, plus 4 by 3z, and here it becomes plus 8 by 3 equal to 0. Isn't it? Plus 8 by 3, or it is minus 8 by 3, I think. Okay, it is minus 8 by 3 equal to 0, and multiplying with a 3, we can write this as 7x minus 5y plus 4z minus 8 equal to 0. This is the equation of the plane passing through the intersection of the given planes. Clear? Is it clear? Okay, now try one more question. Find the vector equation of the plane Find the vector equation of the plane passing through the intersection of the planes r dot 2i plus 2j minus 2i plus 2j minus 3k is equal to 7, then r dot 2i plus 5j plus 2i plus 5j plus 3k is equal to 9, and through the point 2, 1, 3. Find the vector equation of the plane passing through the intersection of the planes r dot 2i plus 2j minus 3k equal to 7 and r dot 2i plus 5j plus 3k equal to 9 and through the point 2, 1, 3. We have to follow the same procedure. In the previous question it is given in Cartesian form. Here it is given in vector form. That's the only difference. So it is the required equation is r dot. See, we can write this as 2i plus 2j minus 3k plus lambda into 2i plus 5j plus 3k. This is equal to, right side is 7 plus 9 lambda. Okay, inside this bracket we can group the terms. R dot 2 plus 2 lambda I plus 2 plus 5 lambda j, then plus minus 3 plus 3 lambda k. This is equal to 7 plus 9 lambda. Grouping the terms here, 2 plus 2 lambda I, then plus 2 plus 5 lambda j, then minus 3 plus 3 lambda k. This is equal to 7 plus 9 lambda. Since we are taking the dot product with vector r, you can write this as 2 plus 2 lambda x plus 2 plus 5 lambda y plus minus 3 plus 3 lambda z. And it satisfies, this point satisfies the equation. So you can substitute the value for x, y and z as 2, 1, 3. Solve and get the value of lambda. Okay, this can be written as 2 plus 2 lambda x. Consider this as equation 1. And we are taking the dot product with vector r. So you can write this as 2 plus 2 lambda x plus 2 plus 5 lambda y plus minus 3 plus 3 lambda z equals 7 plus 9 lambda. This 2, 1, 3 satisfies this equation. Two plus 2 lambda into 2 plus 2 plus 5 lambda into 1 plus minus 3 plus 3 lambda into 3 is equal to 7 plus 9 lambda. Solve this and get the value of lambda. So the value of lambda is, okay, it is 10 by 9. You will get the value of lambda as 10 by 9. Now substitute this value in equation 1. You will get the required equation. Okay, this is, you will get it as, I think it is 38i, right? $68J, then plus 3K, which is equal to 153. I think on simplifying it, you will get the value equation 1. This is the vector equation of the required plane. Is it right? Got this answer? R dot 38i plus 68j plus 3k is equal to 153. Okay, I hope you got this answer. Let us do one more question from this. Find the equation of the plane through the line of intersection of through the line of intersection of the planes x plus y plus z equals 1 and 2x plus 3y plus 4z equals 5, which is perpendicular to the plane x minus y plus z equal to 0, which is perpendicular to the plane x minus y plus z equal to 0. See, find the equation of the plane through the line of intersection of the planes x plus y plus z equals 1 and 2x plus 3y plus 4z equals 5, which is perpendicular to the plane x minus y plus z equal to 0. So, instead of giving a point here, the condition given to us is the required plane is perpendicular to this. So we have to apply the condition for perpendicularity. So it is equation of the required plane is x plus y plus z plus lambda into 2x plus 3y plus 4z equals 1 plus 5 lambda. This is perpendicular to x minus y plus z equal to 0. So what are the direction ratios of this plane? What are the direction ratios of this plane? See, let us just regroup this. 1 plus 2 lambda x, 1 plus 2 lambda x plus 1 plus 3 lambda y, then plus 1 plus 4 lambda z equals 1 plus 5 lambda. This is the equation of the plane. And what are the direction ratios here? Direction ratios of this plane? Direction ratios are 1 plus 2 lambda, 1 plus 3 lambda and 1 plus 4 lambda. That is A1 is equal to 1 plus 2 lambda. Then B1 is equal to 1 plus 3 lambda and C1 is equal to 1 plus 4 lambda. These are the direction ratios of the required plane, and the direction ratios of the plane which is perpendicular to it, that is A2 is equal to 1, B2 is equal to minus 1 and C2 is equal to 1. Here the coefficient of x is 1, coefficient of y is minus 1, coefficient of z is 1. These are the direction ratios of the second plane. And given that these two planes are perpendicular, so what is the condition for perpendicular planes? Condition for two planes to be perpendicular? For lines and planes, the condition is similar. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So we can apply it here. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Substitute the values and get the value of lambda. 1 plus 2 lambda into 1 plus 1 plus 3 lambda into minus 1 plus 1 plus 4 lambda into 1 is equal to 0. Get the value of lambda. Just remember this, while you are considering lines, you can use small letters here, A1, B1, C1, A2, B2, C2. In case of planes, capital letters A1, B1, C1, A2, B2, C2. Okay, on simplifying this, you will get the value of lambda as minus 1 by 3. Lambda is equal to minus 1 by 3. Substitute the value here in this equation. Value of lambda here in equation 1. Okay, it is minus 1 by 3. Value of lambda is minus 1 by 3. Substitute the value of lambda in equation 1. What about the equation? Okay, it is x minus z plus 2 equal to 0, right? So with this, the content of this chapter is over. And let us do problems from miscellaneous exercise. Okay, now for the question, find the angle between the lines. Find the angle between the lines whose direction ratios are can you hear now? Okay. See, here it is. Find the angle between the lines whose direction ratios are A, B, C and B minus C, C minus A, A minus B. Okay. So we are considering two lines here. You know that how to find the angle between two lines. Cos theta is equal to modulus of A1A2 plus B1B2 plus C1C2 divided by A1 root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. where A1, B1, C1 are the direction ratios of the first line and A2, B2, C2 are the direction ratios of the second line. So that are given to us. First find A1, A2 plus B1, B2 plus C1, C2. Find out this A1, A2 plus B1, B2 plus C1, C2. What's the value? It is equal to 0. Okay. This A1, A2 plus B1, B2 plus C1, C2 becomes 0. And here, see, whatever be the denominator, cos theta is equal to 0. Numerator becomes 0. So, the value of cos theta is equal to 0. That implies theta is equal to 90 degree. Is it clear? Okay, let us do another one. Find the equation of a line parallel to x-axis and passing through the origin. Find the equation of a line parallel to x-axis and passing through the origin. So you know that if we have to write the equation of a line, we require a point and a parallel vector or two given points. Okay, two different cases are there. A given point and a parallel vector. So here this first case is given passing through the origin. So one point is given to us, it is 0, 0, 0 and the parallel vector is x-axis. Okay, for this the direction cosines of this x-axis is, what are the direction cosines of x-axis? X-axis makes an angle 0 degree with itself, 90 degree with y-axis and 90 degree with the z-axis. Okay, so the direction cosines are cos 0, cos 90 and cos 90. That means it is 1, 0, 0. Okay, the direction cosines of this x-axis are 1, 0, 0. Is it clear? Okay, once again, see parallel vector is given as x-axis in this question. We have to get the direction cosines or direction ratios of the parallel vector. To get that, let us consider the angles here. X-axis makes an angle 0 degree with itself, 90 degree with y-axis, 90 degree with z-axis. So the direction cosines are cos 0, cos 90, cos 90. Cos 0 is 1, cos 90 is 0, cos 90 is 0. So the direction cosines of x-axis 1, 0, 0. Now we know how to write this. Write the equation of the line. Equation of the required line is x minus x1 by a is equal to y minus y1 by x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the general equation. Here given that x1, y1, z1 is 0, 0, 0. A, B, C, the values of A, B and C are 1, 0, 0. Substitute the values here. You will get it as x by 1 equals y by 0 is equal to z by 0. This is what the equation of line. Okay, now the next one. If the lines x minus 1 by minus 3 equals y minus 2 by 2k equals z minus 3 by 2 and x minus 1 by 3k, which is equal to y minus 1 by 1. This is equal to z minus 6 by minus 5 are perpendicular. Find the value of k. Are perpendicular, then find the value of k. If the lines x minus 1 by minus 3 equals y minus 2 by 2k equals z minus 3 by 2 and x minus 1 by 3k equals y minus 1 by 1 equals z minus 6 by minus 5 are perpendicular, find the value of k. What are the direction ratios of the first line? Direction ratios of the first line. See, you have to compare with the standard form. X minus x1 by a equals y minus y1 by b equals z minus z1 by c. So it is minus 3, 2k and 2. It is 2k here. Minus 3, 2k and 2 are the direction ratios of the first line, and the direction ratios of the second line are direction ratios of first line minus 3, 2k and 2. The direction ratios of the second line, three k, 1 and minus 5. So the condition for perpendicular lines, L1 is perpendicular to L2. These two lines are perpendicular. It is given that the two lines are perpendicular. That implies A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Okay, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Substitute the values here and get the value of k. It is minus 10 by 7. Okay, the value of k is equal to minus 10 by 7. So I hope this is clear to you. Revise the whole chapter and in the next class we will do the remaining problems. Okay. Thank you. And have a nice day.